Today's first video example for section 3.4 about concavity. We're going to find where f of x equal x to the fourth plus 8x cubed plus 200 is concave up and concave down. And we're going to find any inflection points. Now for concavity, what we're looking at is where the second derivative is positive and where the second derivative is negative. So we're going to start by finding the first derivative on our way to finding the second derivative. Of course, if we were in the classroom, I'd have you guys tell me exactly what it should be. And I feel confident you would tell me it's 4x cubed plus 24x squared for the first derivative, and then for the second derivative, that is going to be 12x squared plus 48x. Now, just like with the first derivative when we were finding increasing and decreasing intervals, we are going to find the places where the second derivative is 0, and we're going to use that to break up the number line, and then we're going to test values in each subinterval on the number line. So we're going to set the second derivative equal to 0, and to figure out the values where this is going to be 0, I'm going to start out by factoring, and I'm going to pull out the 12x that is common to both terms. That's going to leave us with x plus 4. So we have 12x times x plus 4 equals 0. So that gives us x equals 0 and x equal negative 4 as points where the second derivative is 0. So I'm going to record those values, x equal negative 4 and x equals 0. So f double prime is 0. And then I'm going to erase so that we can continue. Okay, so now we're going to break up the number line using those two values, negative 4 and 0. I'm going to mark with f the second derivative below and f the function above. And then we're going to just choose values in each of these intervals, subintervals. It doesn't matter what value we choose, we just want to choose something that is convenient. And I'm going to write our second derivative down again. And I'm going to write it in its factored form because that is very convenient for figuring out whether the second derivative is positive or negative. I'm going to try that again. So we have f double prime of x is 12x times the quantity x plus 4. Okay, so I'm going to pick, in this first subinterval here, I'm going to pick x equal negative 5. You can choose anything you want, but I'm going to choose negative 5 because it's easy to work with in this case. When we plug in negative 5 to 12x, that's going to give us negative. If we plug in negative 5 to x plus 4, that's going to give us negative 5 plus 4, which is negative 1, so that's negative. So we get negative times negative, so overall that is positive, which means f will be concave up in that segment. And I'm just going to draw a little picture there to remind us of concave up. In the interval between negative 4 and 0, we need to pick a convenient value. So I'm going to choose x equal negative 1. And when we take x equal negative 1 and plug into the second derivative, when we plug into the 12x, that's going to give us a negative. When we plug into the x plus 4, we have negative 1 plus 4, which will be positive 3. So we have negative times positive, so overall that is negative. So we get concave down in that segment. I'm going to draw a little picture to remind us what concave down looks like. And then in our last subinterval, we're going to pick a value. I'm going to choose x equal 1, just because it's easy to work with. When we plug x equal 1 into the factored form, and when we plug it into the 12x, that's going to give us a positive. When we plug into x plus 4, that's also going to give us positive. So we have positive times positive. Overall is positive for the second derivative. So that means f is concave up in that segment. And again, I'm going to draw a little picture. All right. So that means the function f is concave up from negative infinity to negative 4. And then again from 0 to infinity. And then concave down between negative 4 and 0. Okay, now we are also interested in points of inflection, So that means we're looking for where the concavity changes either from up to down or down to up. So we've got 2 points of inflection that show up for our graph of f, because we have a switch from concave up to concave down at x equal -4. So we get a point of inflection right here. And then at x equals 0, we switch from concave down to concave up, so that is a point of inflection right there as well. Now, to get the actual points, we need to know what the function is going to be equal to at x equal -4 and what the function is going to be equal to at x equals 0. So, I'm going to start by recording this over here on the side because I need more space on the board. So we have -4 and 0. We'll come back and fill in the y coordinates as soon as we work those out. Okay, so f of -4, so this will be -4 to the 4th power plus 8 times -4 to the 3rd power plus 200. And if you put that into your calculator, you're going to find that is equal to -56. So one of our inflection points is at -4, -56. And then for the other inflection point, we're going to plug in 0, so we'll get 0 to the 4th plus 8 times 0 to the 3rd plus 200, so that's 0 plus 200, and we end up with 200. So our second inflection point is at 0, 200.